guys, back again. I love it. Welcome back. Herbs class. We got 5 more minutes of math here, but this time we're talking distance. Now, not a distance that you measure with a ruler or anything like that. We're talking about finding the distance between 2 points on a graph or like a coordinate axis. Let me show you what I'm talking about. Yeah, like that. That's what I'm talking about. Now, I went ahead and picked some easy numbers to work with on purpose because I want us to get this process down first, and then we'll kick it up with some good numbers. All right? So, if I want to find the length of this segment or the distance between these points, there's a formula we can use. Of course, it looks like this. Yeah, distance formula looks just like that. So, a couple of things to notice here. So, notice my x's are in parentheses with each other grouped together because we're going to find the distance, the difference, or actually the distance between these two x values. We're also going to do the same thing for the y's. We're going to find the difference or the distance between these y values. We're going to use these two distances to find our overall total distance. You ever notice how it looks like a right triangle? Yeah, that's exactly where this comes from. This is Pythagoras' theorem written in a different way. Pythagoras' theorem is another video. Make sure you check that out if you don't know what I'm talking about. But let's work this out here. Let's label our points. Yeah, I got 2 points. Each point has an x and a y. I label my x's red so you can see the horizontal change. And then I'll label my y's blue so you can see the vertical change. Let's just plug them into this formula real quick. Just like that. Now, I cannot promise you, and I won't promise you, that these numbers are going to be this clean and this easy. But don't worry about it. We're going to kick this up with some real numbers in a second. Let's just learn the process first. All right, so here we go. Let's work out some arithmetic. We know how to do this. Exactly right. 8 squared plus 6 squared, 64 plus 36, 100. We know what the square root of 100 is. Bang! Exactly right. And when you think about it, we could have did that with the right triangle, right? Yeah! We know that 8 squared plus 6 squared equals 10 squared. Works out for distance too. Turns out that distance is just the hypotenuse of that right triangle. Yeah, keep that in mind when you're working these distance problems out. I got one other way to look at this though. Let's go back to the original distance formula. Yeah, looks something like this. Now, to take some of these subscripts out and all of these little small numbers that are maybe a little bit confusing, when you think about the difference between these x's, think the distance between those x's on like a number line, right? So instead of calling this x2 minus x1, let's make it something simpler like the x distance, right? Over here, our x distance was 8 because that's how far it was between our two x values. Same thing for the y. Y distance squared. The y distance is how far we went up from our original point to our end point, 6. We went up 6 spaces. Let's put another problem up here with some tougher numbers and see if you know what I'm talking about. Okay, I promised you some real numbers. We got some real numbers. Let's find the distance between these 2 points. We don't need a graph. We're going to find it using this formula right here. X distance, y distance. So let's think about that as 2 separate distances. How far apart are the x values? How far apart are the y values? I'm talking about how far apart on a number line. How far apart are -3 and -6 on a number line? Yeah, on this type of number line. How far apart are those 2 numbers? How many spaces? 1, 2, 3 spaces. My x distance, the distance between these x's is 3. You know where I'll put that? Right there. Exactly right. Don't worry about negatives. Distance can never be negative. We're squaring numbers here. You can't get a negative number after you square it. Nope. Same thing for the y's. How far apart are 4 and -1 on a number line? Yeah, that number line. How many spaces? 1, 2, 3, 4, 5. Where do I put that 5? That's the distance between my y's, so I put that 5. Right there. Exactly right. Work out some arithmetic. Bang. Yeah. 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. Now, it won't always work out like the perfect example from before. Sometimes you get a square root that you can't simplify. That's how you do it, man. That's how you find the distance between 2 points. Thanks for checking this out, man. I hope it helps. Let me know if I can help more. Bye.